This video will cover the quotient rule 12.4. So today we'll learn to differentiate functions using the quotient rule. So what do we actually use the quotient rule for? If you notice, when we learned about the product rule, is u times v, so it's a product of two functions. Now for the quotient rule, if you have guessed it, okay, it deals with a what I call a fraction itself. So there'll be u divided by v. So recall, in the product rule, I said always memorize v differentiate u with respect to x plus u differentiate v with respect to x. Start with the what I call v first, and this is y. In the quotient rule, which you also have to memorize, okay, so it's v differentiate u with respect to x minus, okay, take note, this is minus u differentiating v with respect to x divided by v squared itself. Hence, if you memorize that v starts first, if you use product rule, you move on to a quotient rule, it eliminates the what I call confusion that you may face. Okay, now first and foremost, let's move on to the quotient rule itself. So now if you notice, for example 9, there's u divided by v. So u is 3x minus 1. You differentiate u with respect to x, you just get a 3 over here. Similarly, v is 2x squared plus 1. Differentiating that, you get, with respect to x, you get 4x itself. So now let's apply the quotient rule. V multiply to the you differentiate u with respect to x is 3 minus u here differentiate v with respect to x divided by v squared. So if you just expand, okay, and then you expand and you simplify, you will get this in your for dy dx, right, for this function itself. Okay, I suggest to you to pause the video now, okay, and try 9 itself. Okay, so this is the question for 9. Okay, I've written out for you, okay, the formula itself, okay, on how you can use the quotient rule. So remember, the numerator is u, the denominator is v. And we'll carry on in 3, 2, 1. Okay, if you have done, okay, u is 4x plus 1. Differentiating u with respect to x, you get 4. V is 2x squared minus 1. Differentiating v with respect to x, you get 4x itself. Now, okay, we apply the quotient rule. V, then du dx minus u, you differentiate v with respect to x over v squared over here. So if you work everything out in the numerator, you just do the expansion and be very careful, you will get this expression for differentiating y with respect to x for try 9. Okay, example 10. Example 10 comes in two parts, okay, whereby the first part, they will get you to differentiate square root of 3x minus 1 with respect to x. So if I just differentiate that, the half, you bring it down, power half minus 1 gives you negative half. Differentiating, okay, using the chain rule, inside this is a 3. Okay, so what we get is, I've expressed this in positive index form, so I put it down into the denominator itself. So this is differentiating square root of 3x minus 1. So now that we have part 2, where we have this expression, okay, when u is equals to 2x and v is in the denominator. So first, if I differentiate u with respect to x, 2x differentiated, you get 2. This, please don't redo this, we just did this like no above, just down here. So you differentiate v with respect to x, you get this expression over here. Now applying my quotient rule, so v times differentiating u with respect to x minus u differentiate v with respect to x over v squared. Square root of 3x minus 1 square simply gives you 3x minus 1, which is reflected over here in the denominator. Now you notice that we have a slight issue here. Oh, there is a denominator in the numerator. Sounds like the Dr. Soy's book here. So again, there's a denominator in the numerator. So how do we get rid of this denominator? Simply, we can multiply by square root of 3x minus 1. How does this help? This to this term, what happens is you eliminate 3x minus 1. Okay, then square root of 3x minus 1, you multiply to this term. Square root of 3x minus 1 multiply to square root of 3x minus 1, you simply get 3x minus 1 by itself. Then don't forget that the 2 and the 2 here will eliminate. So if I had multiplied square root of 3x minus 1 to my numerator, don't forget to multiply 3x minus 1 to the denominator as well. So if I've done that, what I will get is this expression over here. Okay, so if you simplify the numerator, okay, you will get this, and this is our denominator, and we have shown what the question actually wants us to show. Okay, please master this skill. Okay, as try 10 now. Okay, so in try 10 itself, okay, what we want to do is it follows what we did in example 10. So first they get you to differentiate square root of 2x minus 1 with respect to x. After that, okay, they give you y is equals to 1 minus x divided by square root of 2x minus 1. Then what we need to do, right, is to apply the quotient rule. This is u and this is v. Apply the quotient rule, right, and show this. So now, okay, let me give you some time, okay, to try this, and I'll move on in 3, 2, 1, let's go. Okay, so first and foremost, in part 1, I just differentiate square root of 2x minus 1. Same thing, half, you bring it down. 1 minus half, it gets negative half. What's in the bracket? 2x minus 1, differentiate, you get a 2. You simplify. 2 and 2 eliminates. Then you express this in positive index form. Hence, I get 1 over square root of 2x minus 1. So that is part 1, quite easily done. So let's move on to part 2. Okay, part 2, what they want us to do is to differentiate. So u is 1 minus x and v is square root of 2x minus 1. So if u is 1 minus x, differentiating that, I get negative 1. V is this, please don't redo this. We have this from above. We get 1 over square root of 2x minus 1. Applying the quotient rule, what we do is here, v du dx minus u times dv dx over v squared. Same thing again, notice that there is a denominator in the numerator. So what I can do here is I multiply square root of 2x minus 1 in my numerator. I multiply square root of 2x minus 1 in my denominator. Okay, see what this does? This times this, you just get 2x minus 1. The negative 1 is still there. This times this, okay, you will eliminate the square root of 2x minus 1. For the denominator, you just get an extra square root of 2x minus 1. If all that is done correctly, what you will get is this term over here, this expression rather, and if you simplify, the numerator, what you will get is negative x in the numerator. Denominator cannot be further simplified. We leave it alone, and it is shown. And this concludes 12.4, the quotient rule. Thank you for watching.